Hello, hello, hello. We are back talking about Chapter 4, Proportional Relationships. And we are starting with Lesson 3, Solving Proportions. So solving a proportion is just like solving an equation involving fractions, okay? You can multiply both sides of the equation by the denominator of the fraction containing the variable. If the variable is in the denominator, invert both of the fractions in the proportion. So let's go ahead and look at this problem right here. We have, this is a proportion, it's a fraction equaling another one. And we don't know what n is, so we need to figure out what n is. And we can just solve it just like we solved equations. We need to get n by itself. So right now, is n by itself on this side of the equation? The answer is no. We have n divided by 7. So we have to do the inverse operation of division, which is multiplication. So I'm going to multiply both sides by 7. This is going to become 7 over 1. When we have fractions, we always look to cross cancel, right? And then, so when I look at this, I see that there's a common factor of 7. 7 goes into 7 one time. 7 goes into 7 one time. Everything's 1. 1 times n is just n. Now we have n by itself. Now we're going to go ahead and simplify this side. I have two fractions, 20 over 28 times 7 over 1. So I'm going to look to cross cancel first. I'm seeing if there's any common factors between 1 and 20, and no, there's not. What about 7 and 28? Yes, 7 is a common factor. 7 goes into 7 one time, and 7 goes into 28 4 times. So then we multiply across. 20 times 1 is 20, all over 4 times 1, which is 4. And I can really reduce this. 20 divided by 4 is just 5. So that means that n equals 5. So that's how you can use proportions to figure out what variables are. Now let's look at this right here. We have, notice that here the variable was in the top part of the fraction. Well, here the variable is on the bottom, and we really don't want the variable on the bottom. So what we're going to do is we're going to invert both fractions. We're going to do that first. And how you invert a fraction is really you take everything that's on the top and everything that's on the bottom, and you just invert them, which means you just switch them, right? So everything that's on the top, x equals 6 over, okay, so that's x equals 6, that's what was on the top. And then everything that's on the top is going to go down to the bottom. So the 12 is going to be inverted down equals 9 right there. And so we just inverted the fractions. We put the bottom and put everything on the bottom on the top, and everything on the top, we put it on the bottom. And that's okay. It still maintains its proportional relationship. Now we're just going to solve for x and get x by itself on this side. We have x in the top. The variable's in the top part of the fraction where we need it. We can never figure out what x is when it's in the bottom of a fraction. So we always have to get x to the top. And so one way that you can do that is by inverting both fractions, which is what we did. So now x is on top where we need it. So we need to get x by itself. And right now x is not by itself. X is being divided by 12. So we need to do the inverse operation of division, which would be multiplication. So we're going to multiply both sides by 12. And it's going to be 12 over 1. Okay? So these 12s are going to cancel out and become 1. 1 times x is just x. Equals, and then we have this fraction here. We're going to look to cross cancel. Is there a common factor between 9 and 12? I would say yes, there's 3. 3 goes into 9 3 times. 3 goes into 12 4 times. And now we're just going to multiply across. 6 times 4 is 24. Divided by 3 times 1 is 3. And then we can simplify this because this is 24 divided by 3, which is 8. So x is equal to 8. That is the answer. All right? So that's how you solve proportions when there's a variable. So we're going to just go over a couple here. All right? So we're going to work on these together. So we're trying to determine what A is. A is our variable. We need to get A by itself. So right now, A is not by itself. It's being divided by 2, so we have to do the inverse operation of division, which would be multiplication. So we're going to multiply both sides by 2. These 2's cancel out, becomes 1. 1 times A is just A. And then right over here, we look to cross cancel. The common factor between 2 and 18 is 2. 2 goes into 2 1 time, 2 goes into 18 9 times, and then we multiply across. 27 times 1 is 27. Divided by 9 times 1 is 9. And then we can simplify this further. 27 divided by 9 is actually equal to 3. So A equals 3. Okay, let's try number 2. Number 2, the variable's on the other side of the equation, and that's okay. That's not a big deal. We just need to get it by itself. And right now it's being divided by 9, so we need to do the inverse operation of division, which would be multiplication. So we're going to multiply both sides by 9. Or 9 over 1 is the same thing. So these cancel out and become 1. This is all 1 times n, so now we have n by itself, which is fantastic. Now over here, we're going to look to cross cancel. 1 and 8 can't do anything there. The 9 and the 12, we can. They both have a common factor of 3. Yes, 3 goes into 9 3 times, and 3 goes into 12 4 times. So then we just multiply across. We have 3 times 8, which is 24, and 1 times 4, which is 4. We can simplify this a little bit further. This is 24 divided by 4, which ends up being 6. So 6 is equal to n, and I always like writing the variable on the left side. So n equals 6 is our final answer. Perfect. Okay, on to number 3. Now with number 3, the variable is in the bottom of the fraction. And we can never figure out what the variable is when it's on the bottom. So we need to invert this proportion. So everything that's on the bottom, we're going to flip to the top. So it's going to be t equals 6 divided by everything on the top is going to flip to the bottom. 10 over 4. Okay, so we just inverted it. We switched everything. Now our variable is on the top where we want it to be. Okay, and then we just need to solve for t, get t by itself. Well, t is not by itself. It's divided by 10, so we need to do the inverse operation of division, which would be multiplication of 10 to both sides. Those cancel and become 1, and 1 times t is t. And then over here, make that 10 over 1. I'm going to look to cross cancel. I can't do anything with the 1 and 6, but the 4 and 10, do they have a common factor? They do. They have a common factor of 2. 2 goes into 4 2 times, and 2 goes into 10 5 times. And then I can just multiply across. 6 times 5 is 30 over 2 times 1 is 2. So I have 30 over 2, or 30 divided by 2, and I can simplify that. 30 divided by 2 is actually the same thing as 15. Okay? Perfect. So now I want you to go ahead and try 4, 5, and 6 on your own. Just use your wonderful algebra skills that you've been working on. And remember that whenever the variable is on the bottom of the fraction, you can never figure out what it is. You have to invert it. So the variable, invert the whole proportion. So the variable is in the top part of the fraction. So where's our friend? Oh, here comes the pause dragon, reminding you that now it is time to pause your device. Work out problems 4, 5, and 6, and when you get done, press play, and we will see how you did. All right, see you in a bit. See you in a bit. All right, we are back with problem number 4. We are trying to figure out what x is, so we need to get x by itself. Right now, x is being divided by 15, so we have to do the inverse operation of 15, which would be multiplication. So I'm going to multiply both sides by 15. Don't have much space there. The 15s cancel out. I'm left with x here, and this is 15 over 1. So I look to cross cancel. Is there a common factor between 10 and 15? The answer is yes. 5 goes into 10 2 times, and 5 goes into 15 3 times. Then I just multiply across. 8 times 3 is 24, divided by 2 times 1, which is 2. I end up with 24 divided by 2, which is actually the same thing as 12. Okay, so if you got 12, great job. Okay, let's move on to number 5. 5, we're trying to get W by itself. And I think I'm gonna run out of space, so I'm gonna have to rewrite this. 7/3 equals W over 18. We're trying to get W by itself. Right now, W is being divided by 18, so I'm gonna have to do the inverse operation of division, and I'm gonna have to multiply both sides by 18. Okay, 18 over 1. Those are gonna cancel out and become 1. 1 times W is just W. Over here, I'm looking to cross cancel. I can't do anything with the 7 and the 1, but I can with the 18 and 3. They have a common factor of 3. Yes, 3 goes into 3 one time. 3 goes into 18 6 times. Now I just multiply across. 6 times 7 is 42. 1 times 1 is just 1. And 42 over 1 is just the same thing as 42. And I'm going to rewrite it as W equals 42. So if you got 42, great job. On to problem 6. So what you should immediately see with problem 6 is that our variable is exactly where we don't want it to be, on the bottom. We can't figure it out what it is on the bottom. So we're going to have to invert this entire proportion. So everything on the bottom is going to go to the top, and everything on the top is going to go to the bottom. So I'm just going to rewrite this. 2 equals C. Now everything from the top, from the bottom is on the top, and then everything from the bottom, the top, is going to go to the bottom. Okay, so the 3 is going to the bottom and the 15 is going to the bottom. Perfect, okay? Now, since C is on the top of the fraction, I can figure out what it is. So I need to get it by itself. It's not by itself. It's being divided by 15 right now, so I need to do the inverse operation of division, which would be multiplication. So I'm going to multiply both sides by 15. Okay, so yeah, those are going to cancel and become 1. This is just 1 times C, which is equal to C. I'm going to make this 15 over 1. I can't do anything. I'm going to multiply these, so I got to look to cross cancel first. I can't do anything with the 1 and 2. What about the 15 and 3? Do they have any common factors? Yes, they do. They have the common factor of 3. 3 goes into 3 one time. 3 goes into 15 5 times. So now I can just multiply across. 5 times 2 is 10 over 1 times 1 is 1. And 10 over 1 is just the same thing as 10. So I'm just going to rewrite this as C equals 10. So if you got all 3 of those right, yokodenki mashita. You did a good job. Okay, on to the next page here. All right, so you can use proportions to solve word problems. And really, proportions are used so much in word problems. If you can know how to do proportions, you can really solve a lot of word problems using the skills that you're going to learn today. So let's look at this word problem here, and I'll show you how it works. So a fruit punch is made with 32 ounces of ginger ale for every 12 ounces of frozen orange juice concentrate. So we have some key information here. 32 ounces of ginger ale. And then they use the word for. And when we were talking about rates, that word is actually the same thing as 2. So what they're giving us right now is a fraction. This is on the top part of the fraction. This is the fraction. And then these words over here are what's going to be on the bottom. So every 12 ounces of frozen orange juice goes on the bottom of the fraction, orange juice concentrate. The question is, how much ginger ale should you use for 30 ounces of orange juice concentrate? Okay. So what we're going to do, ginger ale, that is referring here. So it wants to know how much ginger ale should you use for 30 ounces of orange juice concentrate. Okay. Okay, so with this information, what we can do is we can set up a proportion comparing the amounts of ginger ale to, and see how they use the word to because it's a rate, to orange juice concentrate. The first ratio shows the given recipe for the fruit punch. And the recipe is really found in the first sentence. A fruit punch is made with, so it's giving us the recipe, 32 ounces of ginger ale to every 12 ounces of frozen orange juice concentrate. So remember, 2 is, that's where the fraction goes. In front of the fraction is what goes on top, ginger ale. After the word 2 is the orange juice concentrate, which goes on the bottom. So if you see here, 32 right here goes with the ginger ale here. And then the orange juice concentrate in the recipe is 12 ounces. So 12 ounces of orange juice concentrate here. So we have the ginger ale over the orange juice concentrate. There's 32 ounces of ginger ale to 12 ounces of orange juice concentrate. Okay, now that equals, it says how much ginger ale should you use? So that's what we don't know. So that's why there is a variable there, G, for ginger ale. We don't know how much ginger ale we should use if we want to make 30 ounces of orange juice concentrate. So we're making more ounces. We need to figure out how much ginger ale we're going to use, but we want it to have the same taste, so it needs to be proportional to this recipe of 32 ounces of ginger ale to 12 ounces of orange juice. So that's how you set up the proportion there. Now, once you can set it up, you're just going to use your algebra to solve for G. So I'm going to rewrite it here. 32 over 12 equals G over 30. And we're just going to go ahead and get G by itself. Well, G isn't by itself right now. Right now it's being divided by 30. So we need to do the inverse operation of division, which is multiplication. We need to multiply both sides by 30. Okay, so when we do that, the 30s cancel out and become 1. 1 times G is G. We've now isolated G, and G is by itself. Now we need to do the simplification over here. So let's look to, can't cross-cancel anything there, but can we cross-cancel anything here? Is there a common factor between 30 and 12? And I would say yes, there is. There is a common factor of 6. 6 goes into 30 5 times, and 6 goes into into 12 2 times. Okay, so we can't cancel anything else now, so we are going to multiply across. We're going to go 32 times 5, and I don't know what that is off the top of my head, so I'm going to figure that out. 32 times 5, 5 times 2 is 10, write the 0, carry the 1. 5 times 3 is 15, plus 1 is 16. So we have 160 over 1 times 2, which is 2. And I know that those are both even, so I know that 160 is divisible by 2. So I'm going to divide 160 by 2 right over here. So 160 divided by 2. 2 does not go into the 1, but it does go into 16. How many times does 2 go into 16? It goes in 8 times. So 8 times 2 is 16. And then 16 take away 16 is 0. We drop down this 0. 2 doesn't go in there. So yeah, boom. Okay, so that means that we need 80 ounces of ginger ale. Sorry, I just flipped that. But 160 divided by 2 is 80, and I kind of just flipped the order. So this says you should use 80 ounces of ginger ale for 30 ounces of frozen orange juice concentrate. So that's how that works, using a word problem and setting up a proportion so you can solve it. So let's go ahead and work on some other story problems together. Let's do number 7. It says, pecans cost $8.25 for 3 pounds. What is the cost of 5 pounds of pecans? Okay, so if you see here, the word for, that is kind of like the word to. So what we're doing is we're putting dollars on top and pounds on the bottom. So we need to put $8.25 on top and 3 pounds on the bottom, okay? It says, what is the cost of 5 pounds of pecans? So this is where we set up our proportion. We don't know the cost. The cost goes on top. It's talking about the dollars. So we don't know that, so that's going to be our variable. So I'm going to put X right there. It says, what is the cost for 5 pounds of pecans? Well, pecans, pounds goes on the bottom, so we put it right there. And there we have our proportion. Okay, we have 825 over 3 equals X over 5. And we're just going to solve for X. We want to know what the cost is for 5 pounds, so we need to get X by itself. So I have to, right now there's a 5. X is being divided by 5, so we have to do the inverse operation of division, which would be multiplication. So we're going to multiply both sides by 5. Those 5s cancel out and become 1, and that ends up being X. And then over here, I have to I'm multiplying, so I have to look to cross cancel, and I can't cross cancel anything, so I'm just gonna have to multiply across. So I'm gonna go over here to the side and go 825 times 5. 5 times 5 is 25, write the 5, carry the 2. 5 times 2 is 10, plus 2 is 12, carry the 1. 5 times 8 is 40, plus 1 is 41. And yeah, that's it. Now I'm multiplying decimals, so I have to count up the decimal places. There's 1, 2 there. That means my answer has to have 2 decimal places as well. So that's where I put the decimal. And so I'm going to have $41.25 over 3. And I need to divide that by 3. So right here, I'm going to go 41.25 divided by 3. 3 goes into 4 one time. 1 times 3 is 3. I'm going to subtract, which is 1. Bring the 1 down. How many times does 3 go into 11? It goes in 3 times. 3 times 3 is 9. Then I subtract. 11 take away 9 is 2. And so then I'm going to drop down this 2. Put the decimal there. Does 3 go into 21? Yes, it does. 7 times. 7 times 3 is 21. And then I subtract 1, and then I bring down the 5 here. And then I have, does 3 go into 15? Yes, it does. 5 times 3 is 15. And I don't have a remainder. So I'm running out of room, so I'm going to kind of move it over here. X equals, or $41.25 divided by 3 is actually equal to $13.75. So that's how much 5 pounds of pecans cost. 5 pounds of pecans cost $13.75. Okay? All right, great. Let's go ahead and move on to problem 8. So problem 8 states that Mandy drove 90 miles in 2 hours at a constant speed. How long would it take her to drive 225 miles at the same speed? So what we have is we have 90 miles in 2 hours. So that's giving us our rate. This is where the 2 comes into play. So the miles are going to go on top and the hours goes on the bottom. So 90 miles is here. So we put 90 in 2 hours. So the hours information goes on the bottom. So we're going to see how long would it take for her to drive 225 miles. 225 miles, that goes on the top. So 225, how long would it take her? So how long? So we don't know the time. So we're going to use T for time. So that's really our proportion right there. Okay, now notice our variable is on the bottom, and that's really, really bad. We can't figure out what it is when it's on the bottom. So we are going to have to invert this proportion, okay? So everything that's on the bottom is going to move to the top. So this is going to be 2 equals T over 2 over 90. Everything on the top is going to go to the bottom. 90 is going to go in the bottom, and 225 is going to go. So we just inverted everything. Okay, great. Okay, now we just need to get T by itself. At the moment, T is not by itself. It's being divided by 225, so we have to do the Inverse operation of division, which would be multiplication. So we have to multiply both sides by 225. Okay. These two 25s cancel out and become 1, and we're left with t. Okay, now we just need to go ahead and see if there is a common factor between 225 and 90. And they both end in a 0 and a 5, so I know that 5 goes into both of them. I don't really know how many times, so I'm going to have to do that math, but I know that 5 goes in. Now, a bigger number probably goes into both of those, but I don't really know what that is off the top of my head. So let's just go ahead and figure out how many times 5 goes into it, and then we'll go from there. So I'm going to go over here on the side, and I'm going to go 225 divided by 5. 5 doesn't go into 2. 5 does go into 22 4 times. 4 times 5 would be 20. We subtract, and then we have 2, that's 0. We bring down the 5. 5 goes into 25 5 times. Okay, so that means that 5 goes into 225 45 times. Okay. And then let's see how many times 5 goes into 90. So now I'm going to divide 90 by 5. 5 goes into 90 one time. 1 times 5 is 5. I subtract 9, take away 5 is 4. Drop down the 0. 5 goes into 48 times. So, yeah. 5 goes into 90 18 times, I'm sorry. I meant to say 18. Okay, so now I'm looking at 45 and 18. Now, these are numbers that I'm kind of more familiar with when I'm comparing 225 and 90. I'm not as familiar with those ones. I mean, I can tell that 5 goes into them. But 45 and 18 are numbers that I'm a lot more familiar with. So when I'm looking at those, I want to ask myself, hey, is there something else that goes into 45 and 18? And what I see is yes. Another number that goes into 45 and 18 is 9. 9 goes into 45 5 times, and 9 goes into 18 2 times. I'm just going to write it there. Okay? So, yeah, but now I can't cancel anything else out. So I'm just going to go ahead and multiply across. So I have 5 times 2, which is 10 over, I'm kind of running out of space, 1 times 2, which is 2. Okay, so I have 10 over 2, and I'm just going to go over here where I have a little bit more space, and I'm going to say, hey, t equals 10 divided by 2 is the same thing as 5. So t equals 5, which means it would take her 5 hours to drive 225 miles at the same speed. Okay, that's the answer. It would take her 5 hours. So we'll just write 5 hours right there. That's how long it would take her. Okay, let's go ahead and move on to problem 9. Problem 9 states that last week Geraldo bought 7 pounds of apples for $5.95. So that's kind of our rate right there. That 4 is the 2. So we're going to have pounds of apples on top, and then for the cost, dollars, is going to go on the bottom, okay? And that is equal to 7 pounds of apples. 7 goes on top with the pounds of apples, and the cost is $5.95, which is on the bottom. Okay, cool. And then it says, this week apples are the same price, and he buys 4 pounds. How much will he pay? So this week he buys 4 pounds of apples. So where's the 4 going to go? Is that going to go on the top or the bottom? Well, we look over here. Well, on the top, that's where the pounds of apples go. So we put the 4 on the top, and we don't know how much he's going to pay, so that's why the dollars, we put an X there on the bottom, because that's what we need to figure out. Well, how much is he going to pay if he buys 4 pounds of apples? So there's our proportion right there. 7 over $5.95 is the same thing as 4 over x. So we have to get x by itself, but what we have to notice is that right now x is on the bottom of the fraction, and we can't figure out what x is when it's on the bottom of the fraction. So we're going to have to invert this entire proportion. So whatever's on the bottom is going to have to go on the top, and whatever's on the top is going to have to go on the bottom. So that's what we're going to do first. We're just going to invert it. So I'm going to put this information on the top. So 595 equals the x is going to go on the top. And then everything on the top is going to go to the bottom. So the 7 is going to go to the bottom, and then the 4 is going to go to the bottom. Just like that. Perfect. Now we have x on the top of the where we need it. So now we just need to get x by itself. Well, right now it's not by itself. It's being divided by 4. So we have to do the inverse operation of division, which would be multiplication. So we're going to multiply both sides by 4, or 4 over 1. Okay, these 4's cancel out and become 1. 1 times x is just x. So we have done our job. We've gotten x by itself. Now we just need to do this math. So we're multiplying fractions. We look to cross-cancel, but we can't cross-cancel anything, so we're just going to have to do this math. So the first thing we're going to have to do is multiply across $5.95 times 4. So I'm going to do that right here. $5.95, I'm going to multiply that by 4. So I'm going to go 4 times 5 is 20. Write the 0, carry the 2. 4 times 9 is 36, plus 2 is 38. So I'm going to write the 8, carry the 3. 4 times 5 is 20, plus 3 is 23. And since I am multiplying decimals, I need to make sure I have the same amount of decimal places. So here, decimal, there's 2 places. That means in my answer, I'm also going to have 2 decimal places. So the decimal goes right there. So far, 4 times $5.95 is $23.80 all over 1 times 7, which is 7. So now I just need to do this division right here to figure out what x equals. So I'm going to go ahead and do that right here. $23.80 divided by 7. So 7 doesn't go into 2, but it does go into 23. It goes in 3 times. 3 times 7 is 21. I subtract 3 times 1. 3 take away 1 is 2. And then 2 take away 2 is 0. I put the decimal up there. I'm going to drop this 8 down. 7 goes into 28 4 times. 4 times 7 is 28. I subtract. There's no remainder. I drop that 0 down. 7 doesn't go into 0. So boom, there's my answer right there. X equals $3.40. So how much will she pay? She'll pay $3.40 for her 4 pounds of apples. All right. So now I want you to go ahead and try problem number 10 on your own. So go ahead and pause, workout number 10, and when you get done, press play and we'll go over the answer. All right, see you in a bit. See you in a bit. Okay, we're back. Let's see how you did on problem 10. It says Aretha can type 55 words per minute. So there we go, right there. 55 words per minute. That word per, that's like our 2, so that tells us where the fraction is going to be. So we have words goes on top, so we have words per, that's the fraction minute. Okay, so minutes goes on the bottom. So 55 words per minute. So 55 goes with the words per minute. 55 words per minute is just 55 words per 1 minute. So 1 goes on the bottom. At that rate, how long will it take her to type a letter containing 935 words? Oh my goodness, that's a lot of words. So we're going to set up our proportion here. 935 words. Words goes on the top, so that means 935 is going to go on the top. And we want to know how long it's going to take, and the time in minutes, that goes on the bottom. So that's going to be our variable. So I'm going to use t for our variable. T for time. So yeah, that's what we're trying to figure out. We're trying to figure out t. So right now you should see that t is on the bottom, and we can never figure out what the variable is when it's on the bottom. So we're going to have to invert this entire proportion. Everything from the bottom is going to have to go to the top, and everything from the top is going to have to go to the bottom. So let's just go ahead and do that. 1 equals t. Now everything from the bottom is on the top. And then now 55 over 935. Okay, great. We inverted the fraction. Now we just need to figure out what t is, and we can figure it out if we get it by itself. So right now, t is being divided by 935. That's a lot of words. So we have to do the inverse operation of division, which is multiplication. We have to multiply both sides by 935. Okay? When we do that, these 935s, they cancel each other out and they just become 1. And 1 times t is t. So now we have t by itself, which is perfect. Now we just need to simplify this over here. 935 over 1. Okay, so these are really big numbers. I'm not necessarily super familiar with these. However, they both end in a 5, so I know that they're both divisible by 5. So what I'm going to do is I'm just going to see how many times 5 goes into both of these numbers. Right off the bat, I know that 5 times 11 is 55. So that means that 5 goes into 55 11 times. But I'm not sure how many times 5 goes into 935. So I'm going to have to do that division over here. So, yeah, let's go ahead and figure out how many times 5 goes into 935. So does 5 go into 9? Yes, it does. It goes in 1 time. 1 times 5 is 5. 9 take away 5 is 4. Okay, then we're going to drop down that 3. Figure out how many times 5 goes into 43. 5 goes into 43 8 times. 8 times 5 is 40. Then I subtract. 3 take away 0 is 3. 4 take away 4 is 0. And then I'm just going to go ahead and drop down that 5. 5 goes into 35 7 times. 7 times 5 is 35, and there's no remainder. So boom, there you go. My answer is 187. That's how many times 5 goes into 935. It goes into 187 times. Okay, I don't know about 11 and 187. So at this point, I'm just going to multiply across. 187 times 1 is 187 over 1 times 11 is 11. So I got 187 divided by 11. I'm just going to go ahead and do that division over here. So 187 divided by 11. Okay, 11, does it go into 1? No. Does 11 go into 18? Yes, it goes in 1 time. 1 times 11 is 11. And then we subtract. 8 take away 1 is 7. 1 take away 1 is 0. And then we drop down to 7. Ooh, that's very, very nice. 11 goes into 77 7 times, because 7 times 11 is 77. Yeah, so there you go. That's our answer. 17 equals T. That means Aretha can type 55 words per minute. At that rate, how long will it take her to type a letter containing 935 words? Well, it's going to take her 17 minutes. That's how long it's going to take her. Man, that's a long time. All right, cool. If you got that right, yoke it, you did a good job, and we will see you next time. Bye-bye.